So, in a perfect world, you will run your code and it'll work like beautifully and everybody's happy and all is right with the world. And in the real world, that's not ever like what actually happens. Usually you run into errors, and it turns out that all errors can basically be broken down into three types. The most basic type is a syntax error, and this is where there's some inaccuracy in your code itself. Mainly, this consists of typos. Typos happens to me all the time. These do, as obnoxious as it is to like track them down and find them, these are the easiest ones to fix. I had that one bit of code where I had false spelled wrong, and so I easily spotted it. The error message with the code gave me a pretty good idea of where to look. I was like, oh yeah, false is spelled wrong. It's not even color coded the way it should be for the true falses and the things. So, I go, I fix the spelling, move on. So, an IDE will usually flag such errors and they'll even give you some sort of guidance as to what the error is. And I'm sure, especially at this point, you all have come across this plenty of times yourselves. That's the first kind of error you might have. The second kind of error is much, much more difficult to figure out. These are logic errors, and this is basically where there's basically a fundamental flaw in, or there's some sort of flaw in how the program itself was designed. The example I did last week where we were doing palindromes and we would check like the first entry of the string and we would check like the third entry of the string. And it turned out that because of the funky way C++ counts things, the first and third are actually numbered 0 and 2. So the logic error was just that we had to shift the number now basically to go from position 2 being the third entry. That was essentially the logical flaw of the error. That also, as far as these kinds of errors go, um, that one is not so bad. You can have errors that are really hard to kind of wrap your head around. And I did some work in like some database systems for a while, and we would have all these criteria where you would have to find males of a certain age group who like maybe lived in a particular state, and there were different ways you had to filter and sort. And if you didn't do it in like the proper sequence, you would end up excluding people that you didn't want to, or you messed up one of your conditions and you ended up including people that were not intended to be included. So logic errors, that quite frankly is probably that is the hardest aspect of debugging, is finding and fixing logical errors. Then there's the third type, which are called runtime errors. These happen when you run the program. So it's not just that like you type something in wrong, and it's not just that like your conceptual design before you even started was like faulty or something. This is something that comes up when the program itself is run. So like an example of a runtime error might be that the user of your program, they are supposed to type in a number because you're asking them for an int, and then Genius over here types in a letter, or instead of typing in the digit 2, they type in the word 2, and you're like, bruh, seriously. And that is when you can throw an error, you can have an exception. These are errors that we kind of expect might happen, and so we're going to provide feedback to the user about what they did wrong. And I have here, uh, it's not me, it's you. A bit of a twist on the. This is probably more honest because it's not you, it's me. I've never bought that like at all. Like the problem is totally the when I've been told it's not me, it's not you, it's me. I'm like, no, no. The problem is definitely it's me. Anyway, so I never believed that. So what do we got? So other things you might run into is like you could like try to open a file. Like last semester we did this thing about file streams, and one of the most basic things you want to do is like, hey, computer, look for this file and open it. Problem might be there's no file. And there could be a couple reasons for this. Either like the name of the file was typed in incorrectly. I'm actually grading Python homework assignments, but this is coming up all the time where I'm having to change the folder directory that the students put in their code so that it matches where the thing is on mine, because my name is not Jay Valdez, for instance. So, you know, just you to tweak it a little bit, it's fine. So, you know, there might be a wrong directory location. These are things that are beyond the programmer's control. And so we get things that we were not expecting to run into. So that's another potential problem that can happen. If you're trying to access a vector, you know, we expect to have 7 elements, but then the user only gives us 5. Because it's like we were expecting, when we said days of the week, we were talking about like an actual legit week, and this person's only thinking about like a work week or something. So we got a list, we're expecting 7 elements, they only give us 5, and that's like what happens when you try to access the 6th element, which isn't there. That could be a runtime error. So all of these examples, the way you deal with them is you basically, this is trying to protect users from themselves. And say what you will about Microsoft, and I mean, I've known people in computing who are like hardcore anti-Microsoft zealots, and they're all like, Linux is the greatest thing ever, and we have this penguin logo, and like Linux is going to take over the world. And I'm like, dude, like just get over it. But although I am very passionately anti-Apple for reasons of my own, which I probably don't need to get into, especially given this school's relationship with Apple. So I should stay mum on my opinions. I will tell you this though, I do not think Steve Jobs is all that great and wonderful. But little too much fanboy love of that guy right there. But I digress. So what I was going to say is, you know, Microsoft, the thing they did have going for them was they were really good at designing software that, buggy and clunky as it may have been, and like weird things where if you went down to like the 10 millionth row in an Excel spreadsheet and typed in the right thing, it would pop open this graphics of like some sort of demon labyrinth. That was like really trippy, and people kind of like raised their eyebrows at that one. But you know, Microsoft was very good at making their programs user-proof, and like this whole notion of a recycle bin that everyone uses. So it's like, hey, bruh, you really want to delete this? And they're like, yes, I want to delete it. And then they put it in a recycle bin. And then you're like, are you really sure you want to delete this? It's like, yes, delete it. And then, you know, so things like that, you know, innovations that Microsoft gave us, because then you're like, crap, why did I delete? Why did you let me delete that? It's like, bruh, I asked you 3 times. It's like, are you really sure you want to delete this? You said yes every time. So protecting users from themselves, that's kind of the idea here. So the general setup that we have is, it's called a try block, or a try and then catch. This is, we've been talking about functions, so this is a way to execute a function. And basically what you do is you try something, so you have a try block, and you try something, and then you have a catch underneath it. And so in the try block, we run a calling function. And when we do, we encounter an error. When this happens, the function generates an exception. That is some sort of note that something went wrong. So when the exception is thrown, the function immediately returns. So it runs into a problem, it stops what it's doing, drops everything, and it's like, okay, I tried this, something broke, I don't know what to do, I'm moving on. And then the calling function goes to the catch function. And when that is executed, that's executed when an exception is caught. So the idea is like it's throwing exceptions. Madalena can't see this, but I'm gesturing for no real reason. It's throwing exceptions, and then the thing is trying to like catch them. You asked me about baseball, so I suppose this is a fitting metaphor. So it tries some code, it catches exceptions, and then there's like a code of like what it's going to do with that exception. And fun fact, vanilla C++ has a little bit of this built in already because that's where these numerical error codes come from in the first place. You leave off in a semicolon. It's like, bruh, I'm expecting a semicolon here. It throws an exception, and then the catch part catches the exception, and it'll display a little message like, hey, bruh, I think there should be a semicolon here. It doesn't actually say that, but I would totally love it if it. I would love it if computer languages like spoke that way. That would be awesome in my view. So anyway, you can have multiple catch blocks after a try blocks, and there are situations where C++ will actually already throw exceptions, which I kind of sort of mentioned. So let's look at some code, shall we? Let's see, what is this? This is an exception for a non-existent file. So we got our usual headers. We got our int main. We're using fstream for file stream. And so what we're going to do is we're going to have fstream in file. That's going to be a name of a file. We're going to have in file dot exceptions, and then from the file, the fstream, we're going to have fail bit. So this is basically accessing in the file stream library the potential failure codes, the exceptions that are there. Then what we're going to do is we're going to try this. We're going to say, hey, in file.open something.dat. Fun fact, that file doesn't exist. Fstream in, we're going to read it in. Then we're going to have a catch thing, and we're going to have an exception here. This is a reference because it's got the ampersand, so it's a pass by reference. And so the catch is actually calling something inside a fail bit. And there's an exception of category, and there's actually a error that's already built into file stream where it's like, this is kind of a common error they were expecting where it's like, hey, bro, the file isn't there, genius. And then you try to read in the file down here, and you're like, just read in the file. So we run this. I suppose I should tell it which language I'm using. And so it does its thing. So it's like error opening file. Oh, imagine that. There was no file there. So there you have it. So that's an example of a try and catch block. And let's see here. So if we include the exceptions from fstream, it includes the ability to throw exceptions for file streams. The exceptions functions takes the exceptions that are being activated. There's a predefined exception called failed bit, and that will throw when the file is not opened correctly. And if an exception is not caught in the try block, the code will skip over the catch block and proceed with the rest of the program. And so this is like a specific example. We'll look at least one more. I forget how many there are. But when you design functions of your own, you can use try and catch blocks to basically attempt to do something and then have like a catch or a backup plan for what it's going to do if it gets entries that it's not expecting.